Alright, so this video is going to explain some methods of how you can solve indices. Okay, so for the first one, which of these numbers is not a rational number? Okay, so if we look at the options given, we can see that 3 over 5 is rational number because it can be divided. You can get 0.6. So this is called a terminating decimal because it has ended. So any number which terminates is a rational number. If you look at the other one, which is the square root of 7, now when you have a prime number in the square root, it means that it's difficult to find the two pairs which you can multiply to get 7. So this number, square root of 7, is called irrational because it doesn't have the numbers which you can multiply to get it. Okay, other numbers are also rational. For instance, 0.6 simply means 6 over 10. Even 0.6 itself, it's a rational number because it has terminated. Okay, so fractions and decimals which terminate are called rational numbers. So 0.6 is a rational number, and -1, 2 over 3 simply means 3 times 1 is 3 plus 2, that's 5 over 3. Okay, so this number is you can divide. You can get 3 into 5 here, it's 1, remainder 2. 3 into 2, it can't, do a point. 3 into 26, that should remain with 2. 3 into 2, it can't, into 26. Okay, so in this case we are observing that the 6 will keep repeating itself or recurring. So a number which gives an answer that goes on and on is also called a rational number. So all these numbers are rational except from the square root of 7. Now for the last number, which is square root of 25, this number is called a rational number because there are two pairs of numbers which you can multiply to get 25. In this case we have 5 times 5 gives us 25. So the square root of 25 is a rational number, but if you look at square root of 7, this is not a rational number. Also the square root of numbers like 5 itself, this is rational. If you look at the square root of 3, even the square root of numbers like 21, not really 21 but 27, because 21 is not a prime number. So all prime numbers, they give irrational answers, which are also called irrational numbers. Right, then we look at our number 2. Okay, so here I'll guide you, then I'll let you to solve it. It says an integer n is such that 80 is less than or equal to n and less than 90, meaning our n, the numbers which make up n, they start from 80, 81, 82, 83, 83, 84, 85, 86, 87, 88, and 89. So the question says less than 90. So Since it's less than 90, it means we stop at 89. Okay, now let's answer question A, which says a multiple of both 3 and 4. So which of these numbers can be divided by 3? Okay, because when you say a multiple, it means 3 should enter that number. And which other number? I mean, the same number should also be divided by 4. So looking at this list of numbers from 8 to 89, you can tell that let's check 85. Let's try 85. 3 into 8, it's 2, remainder 2, and 3 into 25, it can't. Okay, so 85, no. Let's try 84. Yeah, I think 84. 3 into 8, that's 2, remainder 2. 3 into 24, that's 8, because 8 times 3 is 24. So 3 can go into 84, and if we try 4 into 84, we get 21. So the answer here simply means is what? 84. Okay, then we look at B. Now for B, which is a prime number, so which numbers amongst those was a prime number? Okay, so if you look at let's pick 80. How is 83? So 83, I think it's one of the prime numbers from that list which we can find, because it's only divided by 1 and itself. Or this one, you can work it out, you can confirm it for yourself. A factor of 1700. So 1700, which of those numbers can enter here? Okay, let's try 85. We know that we are talking about numbers from 80 to 89, so we are trying 85. We know that 85 plus 85 gives us 0, 16, 17, 170. So 85 into 170, it's 2. 85 into 0, it's 0. So when they say a factor of 1700, the answer is 85, because it's the number which can enter into 1700. Okay, then let's turn to our number 3. Find a prime number which is a factor of 49. Prime numbers. So prime numbers, we know that among them we've got 2, 3, 5, 7. Now a prime number which is a factor, I think we all know that 7 times 7 gives us 49. So 7 is a factor. These two numbers which you multiply to get 49 are called what? Factors. So 7 is a factor of 49. Then an even prime number. Okay, even means divided by 2. In this case, if you look at the prime numbers, okay, just here you can see that 2 is the only even prime number. And now let's check out number 4. Write down all the factors of 21. Factors of 21, these are okay numbers which can enter 21. So we know that 1 can go there times what? Times 21 itself. So these two are factors, both of them. 3, we do know that 3 can go into 21. How many times? That should be 7. Yeah, 7 times 3 is 21. Do you have any other number? I think these are all the factors. Up to 7. I don't think we have got another one. Right, let's answer B. Write down all the factors of 28. So 28, you can work it out yourself, so that we see how good you can be. Hence, find the highest common factor, even C. So we are going to compare 28 factors. Okay, the factors of 28 versus the factors of 21. Then you see the common ones, then you find the HCF, the highest common factor of 28 and 21. I'm sure you can work out C as well, so I'll leave those two for you. Then number 5 says the square root of 9, square root of 15, 49, 16, 64, 121. From the list above, write down a prime number less than 10. So we do know that square root of 9 is what? It's 3, because 3 times 3 is 9. So square root of 9 is 3. Square root of 15, it's which two numbers do we multiply to get 15? Two same numbers. Okay, let's try, because 4 times 4 is 16. Okay, we'll get back to square root of 15. Let's say square root of 49, that's 7. 7 times 7 is 49. Square root of 16, that's 4. 4 times 4 is 16. Square root of 64, 64 is 8. 8 times 8 is 64. And square root of 121 is what? 11. 11 times 11 is 121. So number 1 says a prime number that is less than 10. Now we do know that 3 is a prime number and it's less than 10. So the answer to I'm sure you can answer the questions now, since we know the square roots. So A, it's square root of 9, because square root of 9 is 3. That means a prime number less than 10 is 3, a square root of 9. Or you can put this as your answer, square root of 9. A factor of 22. Which of these answers were found? Okay, 4, 7, 8, what? Which of these can enter 22? Then C, a power of 2. So which of these answers we have listed out is an even number, because a power of 2 is an even number. So which of these is even? Then D, an irrational number. Okay, so we do know that irrational numbers are those which are hard to find for you to multiply to find the two numbers. I think this one, D, can help you. If you look at square root of 15, it's not easy to know the numbers, that the same number that you can multiply twice to get 15. So I think D, it's a square root of 15, because it's hard to find two pairs. So C, you find yourself. B, you find yourself. A, we have found together as that one, 3. Okay, then 6, write each number as a product of prime numbers. So here they have given us 72 is written as 2 power 3 times 3 power 2. Okay, what do they mean? Okay, we're going to use the radar method. So for A, okay, I will solve A, the rest you do it yourself. So if we've got 30, you do like this, right? 30, the prime numbers we have are 2, 3, 5, 7. Okay, we got 7. So we're going to try, since the 30 is even, we'll start with 2. 2 into 30 is what? 15. Then 15 is divisible by 3, so we'll put 3 now. 3 into 15, it's 5 times. Then 5 is divisible by what? 5. 5 into 5 is 1. So the pairs that we have for for 30, it's these ones here. We do 2 times 3 times what? 5. These are the pairs. Okay, now I want to show you a number that has got repeated numbers, like maybe the 2's are 2 of them more. So that was A, 2 times 3 times 5. Then I'll also try to solve B for you to see if you can understand better. For 24, let's draw the ladder. We know that 24 is an even number, so we start with 2. The numbers is 2, 3, 5. These are the numbers we're dividing by. So 2 into 4, 24, it goes 12 times. Then 2 again, 2 can enter 12. 2 into 12, 6. Then 2 into 6, 3. The other number that is entering 3 is 3, which gives us 1. We end there. So we got 3 sets of, we pick these numbers again. 3 sets of 2's is written as 2 power 3 times which other number is there? A 3. So 2 power 3 times 3 is the product of prime factors for 24. So I leave C, D, E, F for you to think around and find. Okay, then 7 says use question 6 to find the highest common factor of each pairs. Okay, says 30 and 24. Okay, so here we found the factors of 30. I think if you remember, I said for 30 it's do we remember? Yeah, we said it's 2 times 3 times 5, right? Which is 2 times 3 is 6, 6 times 5 is 30. Then for 24, it's this one. So we are going to use the answer for 24 and the answer for 30 to find the highest common factor. Okay, so 2, 3, 5 and then 2 times 3. Okay, let's go to the question. So 30, what was 30? 2 times 3 times what? 5. Then 24 was what? 2 power 3 and times what? Times 3, yeah, there was a 3. So we are going to use a method which we okay, so it says find the highest common factor of each pair. We do know here that the common numbers is 2. Okay, 2 is common, 3 is also common. Okay, so in this case we're going to say we don't mind the powers when we're finding the HCF. We just mind the bases. So 2 is common, right? Then we multiply with another common number, which is 3. So what do we get when we do 2 times 3? 6. Therefore the highest common factor of 30 and 24 is what? 6. Okay, so you can use the same method to find the highest common factor for B and C. Right, then the last question is a bit it's a bit different because it says use question 6 to find the lowest common multiple. Okay, lowest common multiples have got a different method. Highest common factor, we picked common numbers, right? 2 was common and 3 was common. Then we multiplied them without paying attention to the power. Here there's a power 3, we didn't pay attention to it. Now when it comes to lowest common multiple, you need so let's say 30. We do know that for 30 we found 2 times 3 times 5, right? This was the product of prime factors. Now for 64, let's work out for 64. 64. Start with 2 into 64. Half is 32. we'll do 2 into 32 is 16. We do 2 into 16, it's 8. 2 into 8 is 4. 2 into 4, it's, what do we put the answer? In here, right? It's 2. Okay. 2 into 4, it's 2. 2 into 2, it's 1. Now, all of them are 2s here. So how many 2s do we have? We've got 1, 2, 3, 4, 5, 6. So 64 is 2 power 6, since there are 6 of them, right? Okay. So 64 is written as 2 power 6. Now, to find the lowest common multiple, this is what we do. We start with the first step for, like, we're finding highest common factor. We identify the common number. Here we have 2 and here we have 2. Now, when we identify the common number, we only choose the one which has the biggest power. So in this case, this 2 has got no power. This 2 has got 6. So we are going to pick 2 power 6 and we are going to ignore this like it's not there. So since we have picked 2 power 6, we'll multiply it with the numbers which remain, like 3 and 5. So times 3 times what? 5. Then 2 power 6, we do know that is 64, right? So 64 times 15. We know that 3 times 5 is 15. So what is 64 times 15? Let's do 5 times 4, it's 20. Okay, so we've got 0, carry 2. 5, 6, 30, 32. Okay, start with a 0. 1, that's 4, and 6. Then what do we get? A 0, 4, 5, 6, and 9. So we get our answer as 960. So the lowest common multiple of 30, lowest common multiple is what? 960. So I want you to use this method to find the answers to B as well as C. Okay, we'll stop here for today. All right.